Hi guys! Welcome to my vlog!
Today, we'll be discussing item number 9 of Problem Set 1. This is supposed to be the first video that I will be uploading on my channel, but unfortunately, it took me a while to write the proof of this item. Today, I will be presenting my idea on the proof of this item. I am not really sure if this proof of mine is correct, so if you have your own idea, your own proof, or any suggestion on my proof, you are free to write your comment on the comment box below. So let's have item number 9 of problem set number 1. And the problem goes like this. Let P be a prime. Prove that P divides m times n raised to P minus n times m raised to P for all integers m and n. Now, I proved this one using proof by contradiction. And here is my proof. Let P be a prime number and m and n be any integers. Now, suppose that no prime P divides m times n raised to P minus n times m raised to P. So, there exists some composite number k such that k divides the quantity m times n raised to P minus n times m raised to P. By division algorithm, we have m times n raised to P minus n times m raised to P equals k times r for some r element of an integer. Now, if you factor out m and n, we get m times n times the quantity n raised to P minus 1 minus m raised to P minus 1 equals k times r. This means that either k divides m times n or k divides the quantity n raised to P minus 1 minus m raised to P minus 1. Now, suppose that k divides the quantity n raised to P minus 1 minus m raised to P minus 1. So, k does not divide m times n. This implies that mn is divisible by a prime p, since we say that mn is not divisible by a composite number k, so it must be divisible by a prime number p. That is, p divides mn. This is a contradiction because if p divides mn, so p will divide m times n raised to P minus n times m raised to P, which is not our assumption. So it is a contradiction. Next, suppose that k divides mn. So k does not divide the quantity n raised to P minus 1 minus m raised to P minus 1. By division algorithm, we have n raised to P minus 1 minus m raised to P minus 1 is not equal to k times s for some s element of an integer. Applying property of exponent, we have n raised to P all over n minus m raised to P all over n is not equal to k times s. Getting the LCD, we have m times n raised to P minus n times m raised to P all over mn is not equal to k times s. Multiplying both sides by m times n, we have m times n raised to P minus n times m raised to P is not equal to k times s times m times n. By the closure property of an integer, s times m times n is also an integer. So, k does not divide quantity m times n raised to P minus n times m raised to P. This is a contradiction because we say in our assumption that k will divide m times n raised to P minus n times m raised to P. So we have a contradiction. Hence, P divides the quantity m times n raised to P minus n times m raised to P. Now, this is my proof of this item. I hope that I did justice to the proof of the item. And if you have any comment or suggestion, or if you have any idea or your own proof of the item, again, you are free to write your comment and proof on the comment box below. Muchas gracias y Dios te bendiga. Thank you so much. See you on my next vlog. Bye-bye!